Okay. So, like she said, my name is Dike Kalu. I have a software company in the U.S., but in Nigeria here, I work with a company, my brother's company actually, called. And today we'll be talking about state management. So let's just go through some definitions. So even more specific, I'm talking about state management using events, which sounds really complicated. But really, an event is, in your application, is just something that happened. So let's say you have a financial application, an event could be payment received. Like, is that simple. And then also state. State is just a set of values in a particular time. So for example, you might store information in your database. The snapshot of what that is at one time is your state. So here's some example. Let's say we're using JSON format, and the PyCon website where everyone registered, this might be a piece of state that existed at one time. There might have been someone named Tunde who had this email and had a Boolean ticket purchased equals true. So that's all I'm talking about, just some facts about a certain person, thing that you store. Furthermore, here's another example of a banking application. So again, the same Tunde example, they have an email, they have an account balance, and an account type. So why does this matter? So really, much of software development is creating state, is retrieving, is updating, and deleting. So here's why it's important. Let's say Tunde thinks that the state of the bank account, right? He logs on that app. He thinks the state of that account balance field is enough to buy this car, right? But then they actually log into the app, and they see all they have in there is enough to buy this bicycle. They're not going to be very ecstatic, and they're probably going to ask what happened, right? So essentially, what happened here is the underlying state of what the user experienced was different from what they expected. And what Tunde will want in that situation is to be able to trace back how the account balance got there. So that's really what this talk is about. So the architecture or methodology I'm proposing is something called event sourcing. I'm proposing a very simplified version of it just to get the idea out there. But essentially, the golden principle is any change of state that happens in your application must be associated with an event. So if someone's bank account changes, there should be some event that you capture. So it's best explain with an example. So let's say we have a logistics company that needs that delivers drugs, pharmacy, prescription drugs, no illegal stuff, and it ships prescription drugs to hospitals. And let's say the initial state in a database somewhere is there's 2,000 antibiotics in in a truck with ID 2, and there's 10,000 tablets of Panadol in truck number 3, and truck number 2 is in Kano, and truck number 3 is in Aba. Straightforward, right? All right. So let's say next day, truck number 2 goes to Lagos. So what you would naturally do in your software is you'll have some code that replaces the value of the location from Kano to Lagos. So now, if you look at it, truck number 2 accurately reflects that it's in Lagos. So furthermore, let's say 12,000 antibiotics are delivered in Lagos. You'll go to that location in your database, you make a query, update it from 20,000 to 8,000. And one more example, you hit a pothole. One of the trucks hit a pothole somewhere. You lose 6,000 pills of in the accident. So you would reduce from 10,000 to 4,000, and then update the location of the truck. So this is just basic stuff you guys are doing in your application anyways. When something happens, you're updating the values that you're storing somewhere in your database. So at the end of this whole example, this is where we are. There's 8,000 antibiotics in truck number 2, which is in Lagos. There's 2,000 Panadol in truck number 3, which is in Jos. But in this example here, we've lost all the details. You've lost that a delivery was made. You've lost that there was an accident. Maybe you're storing that off somewhere, but what happens when you store data like this is a lot of the in-between things that happen are just not captured. So if you guys remember the first principle, any change of state must be associated with an event. This is exactly what an event looks like, right? So something has happened, a truck location. You have an event type that's usually in the past tense. It says that a truck ID number 2 is now in Lagos. So that is like an event. That is an event that your application would emit. And then let's say you're writing a Flask application for it. You have a Flask server that consumes these events. You could just make a post call saying, hey, I have something that happened. There's a truck in a new location. And this is what the code might look like. So you have a Flask app that's taking all the actions that happened. So in this case, let's say it's update truck location. This is just an example of what the code might look like for this example. Let's say truck is a new location. Make the name call actions. That's the post call. So here it would route to the first if statement, update truck location, which has a class there, and let's see what that looks like. So in event-driven application, really 3 things happen, right? Like I said, first an event is generated, then you persist that event, and then you change the state. So this is what that looks like. We have the event that happened, truck moved location. Can you guys see it? All right, cool. You have the truck ID, you have the location, and you have the timestamp, right? So now you have a concrete event that happened. You can never change that. You can never, no one can ever say that didn't happen and you store it off somewhere. You persist the event. And really that's a fake method I made that just says save it in a database somewhere, right? And then here's the part that actually matters. You actually change the state that's in your database. With that event, you can now get the truck from the database, which is just a simple ORM query in Flask SQL Alchemy syntax. You update the location, you commit it to the database, and you're done. So in a lot of times when we're writing apps today, you just kind of get the command, you update it, and you forget it. This is adding an intermediary step of generating an event and then changing the state of your application using that event. So if we go back to the accident in Jos that 6,000 pills were lost, this could be what the API call would look like to notify of that. It's like, okay, we're reporting an accident for truck number 2, that's the location, and it has a array for the losses. And this is what the class I showed you before might look like for report accident action. So the main thing to look here is like when one thing happens, it might generate multiple events. So in this example, the accident generated an event that the truck moved locations and that inventory was lost. So the structure is very similar to the last one. And again, here's the important function kind of blown up, which is a change step. And again, all this does is just takes each of the events that you have and then updates the database with that information. So it seems like a lot of work to, instead of just updating your database, you generate this event and then you update your database from there. What are the benefits of doing that? Well, A is auditing. If you're working in an industry that's maybe highly regulated, like banking, or you're dealing with chemicals or something, it's a lot easier to go through and look at events that happen to see why your database or your state is the way it is. And also something I've done with clients is dashboards, right? A CEO wants to see real time what happens in their business. So if you're having this collection of events happening, and let's say the CEO wants to know every time a truck moves, you can listen to those events coming in and just update a dashboard as they happen. Predictive analysis. I think someone mentioned it, but really you can't do any machine learning, AI, you can't do anything without data. And most companies are not capturing half the stuff that happens in their business. And using a system like this is a way to capture the full story of what happens as part of the business, and you can later leverage that for analysis. So next is system recovery. This actually happened where an app that was built like this crashed. The database went offline or something happened and it crashed, and we needed to get it back to where it was because backups weren't done correctly. So really the events were spared, so we were able to just replay all the events and get back to where we ended up. So capturing events is a really powerful way to kind of manage state in your application. So like me, I got exposed to this pattern. It was lovely. I did it for every single project that I worked on after that. But nothing's for free. You later find out there are a lot of hard things about doing this. Maintaining order of events is not trivial. So like these events happen in order, and if a truck moved from Aba to Port Harcourt and then to Enugu, you have to have those orders intact. So keeping orders of things, especially when you have applications running on multiple nodes, it's very hard and not trivial at all. Again, there's also race conditions. If you're updating state, you want to make sure that everyone that's doing the update has the same version of events at the same time. And lastly, if you're saving every event that happens in your software, that table gets really big if you're saving it in a database, or there are other databases that are made just for that. So the moral of that story was, you don't need to do this, or I didn't need to do this every time. There are probably very few, even though it's great, there's very few applications where this is really needed, and here are some of those. So if you have something that needs to be audited, if you have something that if you also have the time and resources to design it right, because the architecture of this gets really complicated really fast, and then this is probably, and also if whatever goal you have in mind for the application is best achieved using this pattern, then it will probably work for you. And another thing to add to that is, if you have something that must be correct 100% of the time, the data must be correct 100% of the time, there's probably an architecture to look at. So I mentioned in the beginning, this is sometimes referred to as event sourcing. I gave a very shallow overview of it because it would have probably taken a lot longer. Here are some things you can Google. Martin Fowler's blog and book is something I referenced a lot when I first started doing this. There's a bunch of open source libraries that try to solve the problem that this architecture inherently has, which is like you have to store a lot of events. Things have to be fast. You have to retrieve a lot of events sometimes to know what your state is. So there are a lot of software out there, open source software that tackles those problems. So it's really helpful to just go to their GitHub page and take a look. That's an example there. So that's pretty much it. Any questions?